Hello everyone. Thanks for having me here today, and thanks to everyone who's interested in this topic. So for today in this talk, I would like to discuss about my process and methods that I used to find vulnerabilities within Flutter applications. I will also show examples of the sensitive data that can be found by reverse engineering Flutter apps. And lastly, I will go through real-world case examples of how to find these vulnerabilities and how to exploit them. Next is, who am I? Firstly, let me introduce myself. My name is Sabina Llewellyn. I am a penetration tester currently working at Data Farm, and here's my interest and past work. So for today's agenda, it will consist of 6 topics, which are goal of this talk, Flutter introduction, research process and results, types of sensitive data, case examples, and the last topic will be conclusion. So about the goal of this talk, here are the key takeaways that you will get from this talk. Next section is Flutter introduction. So I will give a brief introduction to Flutter. So Flutter is an open source framework developed by Google. It has many advantages, such as using a Dart programming language, which allows the apps to make powerful design capabilities. And another main advantage for Flutter is by it being a single code base, which means it allows developers to write code once and release it on multiple platforms. And with all of these, Flutter's advantages have made it gain its popularity nowadays. Next, we will be going through the research process and the results. And in this research, I would like to focus on Flutter applications for Android only. So here's the overview of what the research process looks like. It consists of 5 steps, which are application gathering, inspection, reverse engineer, scan, and then analyze. So in this process, in this step, we will use Python script with Selenium to bulk download apps from the APK Combo website. And the apps that I chose to download are, I would try to find a list of Flutter apps and apps with high downloads, popular apps. And also I would test on apps on bug bounty programs and vulnerability disclosure programs. And the reason that I use this website to download is because you can't download apps directly from Google Play Store. So after we've gathered all of the applications, we don't really know if those apps are made with Flutter or not. So there has to be a way to verify it. So in this step, which is inspect, I used a bash script to verify if each apps are made with Flutter. So you can do this by checking the ARM64 library, and if the Flutter library is present, it means that the app is made with Flutter. So here's the example of what the bash script looks like. In this example, we gathered 46 apps, and we found that 24 apps are made with Flutter. Next is I would use Flutter as a reverse engineering tool, and I also use bash script to automate this process to reverse engineer all the Flutter apps that I gathered. And for some of you might already be familiar with Flutter. So for some of you who are not be quite familiar with Flutter yet, I will explain it in briefly. So Flutter is a reverse engineering tool for Flutter mobile applications. And the reason that I chose to use Flutter as a reverse engineering tool for Flutter is because of its capability to produce the most output information, which makes the process of analyzing the assemblies much easier. And you can clone this tool from GitHub. Next step is scan. This step of the process, we would then use the output that we got from reverse engineering each apps, and then we would use a scanning tool to find for credentials, and the tool that I used is GitLeaks. And I would use GitLeaks to scan each pp.txt file, which is a dump of static variables and global variables. And I also used bash script to automate the process. So GitLeaks, what is GitLeaks? It is a tool for detecting hard-coded credentials such as passwords, API keys, private keys, access tokens, and so on. And you can clone this tool from GitHub. Next, other than using GitLeaks to scan for secret credentials, I also wrote a bash script to find important keywords that can indicate that there is a secret credential being hard-coded within the app. So the keywords that I would search for are Firebase, key, API key, secret, password, HTTP, and so on. And I also use bash script to automate this process. Next step, which is the last step of this process, which is analyze. Then in this step, I would use the results from using the scanning tools, and I would analyze it with the output from reverse engineering, which are the assemblies and the pp.txt file. And this chart shows that out of approximately 1,000 apps that we have bulk downloaded, 228 apps are Flutter applications. And these are the results from finding the secret credentials that we have found through reverse engineering these 228 Flutter applications. We have found a total of 6 passwords, 4 private key, 61 API key, 19 access token, and 121 API endpoints. Next, I will be displaying examples of sensitive data that can be found by reverse engineering Flutter applications. Here are the passwords that are being hard-coded within the assemblies. These are usually found by examining the assemblies. I came across them while looking at the assemblies, and you can use them to authenticate to the system or use it to decrypt a certain key. Next is API key. For the API keys, I found them by using a scanning tool mostly, and here are the examples of the API keys. The first one is the Stripe secret key. You can notice hence the pattern of the key, which is sk_live, and the API key of the picture below is a Twitter API key and secret. Next are private keys. the private keys in a picture above are found within the Flutter assets of the application, and the private key in the picture below can be found in the assemblies from reverse engineering. Next are access tokens, and these tokens are usually found by using a scanning tool. And the token above is an AWS access token, and the token below is JWT. And about API endpoints, these endpoints are usually found by using a bash script to search for the keyword HTTP. And moving on to the next section, which are case examples, I will be going through these case examples and explain the reproduction steps and explain how to exploit them. So for the first application, this app is used for collecting trophies and achievements when you play certain video games. So, and there is also a subscription and a premium account that you can subscribe to. So there is some kind of financial transaction being used within this app. Sorry. So for the first application, I would start by reverse engineering the app with Flutter. And then I used git leaks to scan the pp.txt file. And the reason that I scanned the pp.txt file is because it contains static variables and global variables, static data. So hard-coded, the secret credentials are static data, hence why I am scanning with pp.txt file. And for this app, I used git leaks and I scanned it and I found the Stripe secret key and also the public key as well. And then I looked up the Stripe's document and found that there is a way to interact to the API via using command line. So I used the command line to query charges from the Stripe account. I was able to find users' address information and credit card details and also last 4 digits of the customer's credit card. Next, I was also able to retrieve the current balance within the Stripe account. So as you can see here on the slides, there is about $3,000 pending within the Stripe account. And I was also able to retrieve files that was uploaded by the admin to the Stripe account. And moving on to the second application. So this application is about managing a football team. The coach can send feedbacks to their players and the football players can track their progress. And yeah, so for the second application, I started by using Flutter to reverse engineer the app. And then I used git leaks to scan the pp.txt file. And this time I was able to locate a header of a private key. So then I was wondering how the private key is being used, so I use ripgrep tool to search for the keyword which is private within the assemblies of the application. And I found an interesting file, and I looked at the assemblies and after analyzing the assemblies, I came to the conclusion that the keys/public.pem is a file that is being called from the application, from somewhere within the application. And I decided to inspect the Flutter's assets. And then that is where I was able to locate the private key of this app. So, for the third application, this app is a dietary habit app. It lets user manage what meal they had and record their emotions after they had a meal, and so on. And you can track calories also. And for this app, I used Flutter to reverse engineer the application. And then next step is I use Git leaks tool to search for hard-coded credentials, and this time I was able to locate the JWT. And then, after I found the JWT, I would want to know how it is being used, so I use ripgrep to find the token where it's used. So I use ripgrep to find the token within the assemblies, and found it located within an assembly file. And not only I just found the token, but I also found some endpoint that can be used with a token as well. So after I looked up what the endpoint was, I found that it is a database which is called Superbase, and I also found that this API can be connected or interacted with via using a command line. And then I tried and used the token and connect to the API, and was able to retrieve further information such as the data structure of the app and also the plugins that they use. And this information can be used as an attack surface to further compromise the app or the system. And for the last application, this is an app that has approximately 5 million downloads, and this app is a part of a vulnerability disclosure program. So what this app does is it allows you to control and customize your IoT gadget. And I started exploiting this tool by reverse engineering this app with Flutter. And then I used Git leaks to scan the pp.txt file, and I was able to locate the AWS access token. So I looked up the AWS's document and found that we still have to find the secret access key in order to configure the AWS. So I started with using the AWS access key to use ripgrep with the token to find where it is located within the assemblies. And I found the file that has the token within the assembly file. And I also found another file with a similar file name, and this file ends with secret.dart. And This file cannot be read directly because it is encrypted, so we have to find a way to decrypt this file. And I did a further analyzing of the assemblies and found that within this assembly file, I was able to find the function that was responsible for calling the S3 bucket, or is a client for the S3 bucket. So what I did was I used the Flutter script, which is generated as an output from using Flutter, and I took the client function's address, and then I used it on the script. And after using the Flutter script, I was able to obtain the AWS secret access key. So, after obtaining the secret access key, then I configured the AWS and I was able to query the IAM identity. And this means that the S3 bucket of the app is accessible. And yeah, that is it for the fourth application. So moving on to the conclusion of this talk. So these secret credentials are especially vulnerable to reverse engineering now that we have an efficient tool to perform that task. And obviously, hard-coding secret credentials within app exposes a significant security risk, and this practice should be avoided at all costs. And that's all from me. Are there any questions? Thank you so much for listening.
Thank you, Sabina.